Hello, and welcome to ATARC's podcast of the Modern Data Experience with Pure Storage. I'm Nick Psaki, Principal Technologist for North American Public Sector with Pure Storage. And joining us today is Rob Albritton from Octo Labs. Rob, thank you for joining us. It's great to have you.
Thanks, Nick. Great to be here with you today. Again, I'm Rob Albritton. I lead Octo Labs, otherwise known as O Labs, our AI Innovation Center at Octo. And Nick, I'd be happy to give the listeners a little intro to O Labs and what we do when you're ready.
This is actually the very first thing I wanted to ask you. So tell us a little bit about O Labs, how it was born, and what you guys are doing today.
Sure. So O Labs is actually about 8 years old or so. So it's not new. However, the current instantiation of it is new. So if we go back 14 years or so, Mehul Sangani founded Octo as a digital modernization, cloud modernization type company. We've really made our name at places like Kessel Run, the software factory up in Boston for the Air Force. At one point, we were the largest contractor up there, or one of the largest. So that's the kind of work we've traditionally done. Over the last 2 years or so, though, we've shifted to what call emerging technology. However, we all know that AI is not emerging. Been around since the 50s, since it was coined at Dartmouth, right? We all know that, but we'll call it for the sake of this discussion, emerging technology. Octo has shifted rapidly over the last 2 years into emerging technologies like AI, blockchain, other types of data science. And as such, we decided to focus our investments on that. So O Labs about 8 years ago was really a AWS sandbox, a digital instantiation, a place where we could go and do prototyping. But again, it was just an AWS sandbox. It wasn't a physical place, brick and mortar, where we could all come together and do innovation. And we've realized about 2 years ago that there is no replacement for that kind of innovation that can be done when you're with other engineers. And so we also realized we needed a incubator of sorts. So you can think of O Labs as an incubator where not only our engineers, but also our government clients. So we work with the US Army, US Marine Corps, both of which have soldiers and engineers that sit on site with us at O Labs. And so the concept is our customers are there on site with us, can feed us requirements, hopefully from the battlefield or as close to it as possible. So real requirements, technical requirements, feed those to our world-class engineers. By the way, we have engineers from, that used to work at Bosch building, self-driving car systems, and ETH in Zurich, Switzerland, doing virtual reality research at the Microsoft and ETH lab, and all over the place, right? So world-class engineers can work together with the end user and rapidly prototype AI solutions and hopefully get them out to the battlefield as quickly as possible. Physically, yeah, go ahead.
I'm sorry, that is absolutely fascinating. Providing a real world workspace for people to ad hoc address imminent or emerging requirements, and having the expertise on staff and on hand to be able to help deliver those solutions and the outcomes. That's actually really tremendous.
Yeah, thank you. We think it's unique. We do understand that there are, there's SoftWorks and DefenseWorks and DIU, and but we think this place O Labs is truly unique in that not only do we have the right personnel on staff. So I should mention not only our AI Center of Excellence, but also our cyber experts, our data science experts, data management, data federation, data mesh, all the different data domains and where the expertise in those domains is necessary to make AI work, right, and build AI enabled solutions. All of those folks are on site with us as well. So all of our centers of excellence, their leadership and their experts sit on site at O Labs with us and with the customer. But it's also a physical investment, right? So we know those people, it's a vessel for those people and that talent to build emerging technology solutions for the government. but we have to have physical capabilities to do those things. So that's where, the physical space description comes into play. So it's 15,000 square feet of innovation space. We built a 20 petaflop supercomputer with actually DGX A100s and pure FlashBlade and truly amazing infrastructure. But not only that, so we can train our models on that and and rapidly iterate on our models, do retraining when models start to degrade and things like that. But we can also take those models and take them right down the hall to our close quarter combat facility and our robotics facility, where we can actually test those AI and ML models, those algorithms that we just developed on the supercomputer, walk down the hall and test them in an operationally relevant environment so that we know that the solutions we're building can be fielded, right? They work in an operationally relevant environment. We're not just building them in a stovepiped, vacuum. And we don't want to build stuff that's going to go out and sit in a Connex container and collect dust, right? We want to know that it's going to work on the battlefield.
Not just theory, but applied artificial intelligence. More importantly, applied solutions driven by artificial intelligence.
That's right.
That's some pretty cutting edge hardware that you've got there. And obviously, we're very pleased and proud to work with you to help build the capability, build the engines necessary to make the race car go. So you mentioned a tremendous swath of the Department of Defense as partners and customers of yours, which is pretty encouraging. Has word gotten out beyond the DoD? Are you guys supporting other elements beyond that? Given the nature of cyber as an example, this seems to be a natural fit for Homeland Security and other other entities within inside the government.
Yeah, actually, we have. So O Labs was built, I would say, primarily to focus on DoD and IC customers. That said, a lot of the solutions we've built, especially the computer vision based solutions, so doing things like aided target recognition, right? So flying a drone and identifying T-72 tanks or whatever the target of interest is, right, in that video, and then telling the end user, the soldier on the ground, hey, there's a target at whatever 8 or 10 digit grid coordinate, go look over there, that kind of thing. That has actually those models, those computer vision models are not all that different than the ones that we use at NIH, for example, to detect cancer cells, right? So there's your answer. Yes, we work with folks at NIH. We work on a really neat project at TTB. So that's where, believe it or not, there are certain labels and things like that that cannot go on alcohol in the United States. You can't put pictures of pregnant women on alcohol labels, things like that. So you can put warnings in words, but not in text, but not pictures. And so we've actually created computer vision algorithms and image similarity search tools and things like that to identify those illicit labels, those illicit images that companies are submitting, trying to get on their alcohol labels. So that was kind of a long-winded way of answering your yes. We do work with a lot of different organizations.
Yeah, a lot of innovation starts off in the DoD and the IC. As I like to say, you do your engineering like your life depends on it, or somebody else's does. But then obviously the products of that are often translatable to other endeavors. And computer vision is probably the most accessible case in point for most folks. So that's really exciting to hear. And if you've proven success in an area where it matters, like the Defense Department and overseas operations, being able to translate that into ways to help better human health and human longevity is pretty darn exciting. So we talked, I guess, a little bit about over the course of 14 years in the evolution to O Labs, you've attracted a lot of interest, a lot of customers, broken a lot of new ground. Can you talk at all about the results of what O Labs has helped their customers accomplish?
Absolutely. So I'll just at a high level describe some of the customers we work with, right? So
Sure.
I talked about a couple of the non-DoD customers. On the DoD side, we work with SOCOM
Mhm.
quite a bit, the U.S. Special Operations Command. We work with the U.S. Army and a couple others, but those in particular, I think we've had a lot of impact on. One of our SOCOM customers, realized that there's just a massive amount of AI-enabled data being generated at the tactical edge, right? So, SOCOM in particular is adopting a lot of AI-enabled solutions, and as they do that, they have not really come up with a good way of managing all the data. And so, one of the solutions we created at O Labs is called CX Edge, and it is essentially you can think of it as a tactical AI brain, so a smart brain piece of software that runs on it runs really on any hardware, but the edge version is on a low size, weight, and power device, basically an embedded GPU. And as all this AI data is being generated by aided target recognition algorithms and you know doing NLP on SIGINT and all kinds of other analytics, right? As that's all being done on the battlefield, CX Edge is designed to manage it. And so before we started working with this customer, they didn't really have a way to manage that data. And so fast forward, this has been done in just 6 months. So 6 months ago, they had no way to manage that data. Now they do. Not only can they manage it at the tactical edge and push it out to the right end user devices, like their night vision goggles or their ATAC phones, Android Team Awareness Kit, or other devices on the battlefield, C2 or C4 ISR devices. They can also federate that data up to the enterprise where perhaps on-prem FlashBlade might be residing, and they can push it up to that device and store it there, or up to C2S on AWS side, or wherever they need to, so that three-letter agencies and national level intelligence analysts can access that tactical data as well. So that's just one example of a very recent project we worked on with one of our customers.
That's fantastic. AI augmented knowledge management. What a tremendous application. Let's talk a little bit about the underlying technologies. How did you guys come to decide on the platforms and the components on which the services, the research, training, operations get developed? What were some of the key characteristics you were looking for to address the needs for doing artificial intelligence in the real world?
Yeah, so because we do a lot of computer vision, and the specific application of it is typically we need answers fast. We need to get data in and do analytics on it, and then get answers out as quickly as possible, right? So throughput is an issue for us. So if you think about that, that throughput, so FlashBlade for one is really good at that, right? So that's one reason. I would say even more importantly though, and it's a very just I don't know how to describe, but one of the most important reasons is maintaining the infrastructure, right? So we don't have a massive IT team. So meaning we don't have 5 sysadmins that can manage our cluster, and all of our data resources. We might have one on any given day, and so it has to be really user friendly. And so that's one reason we chose the AI ready infrastructure. So having the DGX A100s, having our compute with the FlashBlade storage right on top of it, and just the ease of managing that infrastructure and the size and reduced cooling that goes into it. And for all of those reasons, that's why we chose the AI ready infrastructure. I would say also from a strategic perspective and thinking about where our customers are, if you think about needing to deploy some of this stuff on a C-17, for example, transport aircraft. I don't know if it's actually being done right now, but it is possible, right? We can package these things up.
We have a customer. They have a Formula One racing team. they kind of travel around the world with their stacks. And like you said, if you can deliver capability in a half a rack unit, that's, you can put it on a ramp, you can fly it around the world, you can drop it off, and you can power it off of, whatever generators you have at hand. That's an incredibly powerful capability. As we know, especially in the DoD, a lot of the places in the world that you go, they don't have connectivity. There is no cloud. You don't have any communications other than what you bring. So being able to move it where you need it is incredibly powerful. Obviously, another one of those conversational pieces is, I don't want to move the infrastructure, I want to move the algorithm. This is, actually a very good point of view. But being able to move your algorithm to wherever the data is, wherever the point of need is actually part of the magic of a lot of the software infrastructure that we have in the world today, between Kubernetes, cloud, containerization, and the ability to create an algorithm and then deploy it forward, you talked about earlier, which is, obviously of incredible utility, not just to the DoD, but to FEMA, to the Forest Service for firefighting. But also, you said something earlier that I wanted to pick up on, which is AI creates an awful lot of new data and new insights. So just like going through school, once you've made it through 8th grade and you've got fundamentals of algebra, you move on to quadratic equation, polynomials, etc., which spawns a whole new field of learning or expansion of learning for the human mind. AIs are no different. Once you've created a whole bunch of new data, what do you do with it?
That's right.
You point new algorithms at it and say, okay, figure this out.
Right. That's absolutely.
So you need the infrastructure that can not only look at the original source data, but also the products of previous algorithms outputs, and then learn more from that, which again creates this need for continuous retraining and evaluation of new data sets. Having the ability to do that in a lab environment to which your customers have access is probably incredibly beneficial.
It is indeed. Yeah, if you think about so there's a little nano drone made by FLIR called SBS, Soldier Borne System, or Black Hornet. Basically a little drone that fits in the palm of your hand. It's a program of record for the US Army. And the intent is to field one to every single squad in the US Army. So the Army purchased something like 9,000 or 10,000 of these drones. All you have to do is do the back of the envelope math, on your napkin or whatever. And if you're doing aided target recognition and creating targets, detections, or doing 3D reconstruction, doing photogrammetric, reconstruction, building 3D models of compounds and things like that you're flying these drones over. Our calculation was about you'd be generating every single day every single day, every squad would generate about 2 NFL seasons worth of data. So the equivalent, every single squad, every day. There is no way the Army is prepared to manage that kind of data. And so that's why when we talk about we need AI to analyze data. We also need components to be able to deal with the data that the AI is generating, right? And then how do you sift through all that? How do you search through it? You've got to use AI. You've got to use NLP. You've got to use other search techniques. You can't use old school Boolean search techniques to search through that amount of data. It's just not going to happen. So you have to use new approaches, and those are the kind of things we think about in O Labs, and those are the kind of things we're working on with the SOCOMs of the world.
You're sort of giving us a look to the future as well, and the considerations of managing data at scale. Based off of where you've been and how you've gotten here today, what do you guys see as next? Where do you see the evolution of AI capability evolving in the DoD and in other places? And what are some of the technologies that you think are going to be essential in helping address them?
So one of the I would say challenges we've seen, or flat out failures, quite honestly, from some of the Pathfinder AI programs in DoD, is the inability to scale and field these capabilities. So essentially they end up being science fair projects. built in a vacuum, build a ML model that does one thing really well, but it's really not operationalizable, right? So, and the reason is ML models are fragile, virtually all of them. It's just the nature, especially deep neural network based models. It's just the nature of the math, right? The math behind them and the way they're built. They degrade in production, right? So the fundamental lack of understanding of that, especially in DoD, but throughout the US government, federal government, not understanding that ML models, once you train one and then deploy it into production, it has to be maintained. It has to be monitored for concept drift, data drift, other types of degradation in model performance as it is encountering real data on the ground, right, in production. So that's essentially, that's called ML ops, right? So ML ops, that was a long-winded way of saying ML ops is the future, right? ML, machine learning operations, we all know DevOps, we all know DevSecOps and what that is, right? But the ability to do data munging, find your data, prepare your data, label it, put it into a train your data, kick it out the other side, put it into production, then monitor it for degradation, monitor its performance. When it degrades, kick off retraining events using active learning and other processes like that. That's the future. It should be that right now. It is for us at O Labs. We're very focused on ML ops. Without that, ML is just not going to be a scalable capability within the federal government.
Our previous episode of the Modern Data Experience, we had Brett Vaughn from the Department of the Navy, who's the chief AI officer. He said exactly the same thing, that his big focus going forward is actually ML ops across the fleet.
Wow. And I don't know Brett. I've never heard him say that, but I'm glad to hear you say that, because that means we're on the right track. But yeah,
one of the things that, now that you've won the prize, how do you keep it in operations? This is one of the things you talked about earlier when we were talking about the underlying technologies that drive this. The word I think you were looking for is sustainment, which encompasses obviously the support thing, but the lifecycle sustainment of the capability, the amount of people necessary to keep it in operation. But the same thing applies to data custodianship. And obviously the MLs, think of them as, school students. You've got to find out what they know, what they don't know, where they're failing, what they need to learn, what they need to relearn, training and reinforcement, things of that nature. All that stuff is, for a cognitive algorithm, necessary. And you have to approach it in the same way that you approach human cognition. In fact, a lot of our keys for figuring out how to do this, we can observe just from knowing how we teach people and dogs and everything else that has to learn. And machine learning and artificial intelligence, particularly algorithms, are every bit as much iterative as in terms of how they learn as any other learning system. It's the ways in which that happens are different, but the fundamental principles are still pretty much the same. It's remember the famous example of teaching a computer what a cat is, right? But if you decolorized it or you gave it a texturized picture, it couldn't really tell. As long as it was looking at a face, it was fine. That's a cat, that's a dog. If you tell it to look at if you showed a picture of a cat's belly, suddenly lost again. But our brains, and people don't often appreciate this, are the products of billions of microseconds of iterative learning. So when you change the aspect of something, the direction from which you're looking at it, or the context in which you're looking at it, our brains make that adaptation automatically. Now, teaching a computer how to do that, that's hard work. Teaching an algorithm how to understand and see those changes and interpolate what they are, that takes a lot of work. But that's what's happening now, as you said. Taking an algorithm that was designed to do coherent change detection or the detection of specific types of things on the ground and then telling it to look at a cancer pathology slide, computationally, it's the same problem. Algorithmically, it's a different flavor. But we do the same things. We learn to see the world around us, and then we learn areas of specific interest to us. And then sometimes we take those skills and apply them to another problem. and start seeing or understanding a solution to a problem in a different way. Well, that's what AI is doing for us. And you guys are really at the forefront of that by creating the capacity for people to explore how they can employ AI to solve some really fundamental complex challenges and address some really pressing needs. I really appreciate your insights on what are the challenges ahead being ML ops. Okay, now that we've got these things, how do we keep them growing and developing? That's going to be interesting.
If
You
I
guys
can
have
add,
done a lot of, go
if I
ahead.
can add, and if I can add a little more, just a tiny bit more color to that, not
Absolutely.
only ML ops, but it's got to be automated or semi-automated. In
Yeah.
other words, so if you think not just the federal government, there's a lack of data science and ML tech talent, right? Throughout the industry, right? They're just you, especially in the federal government, you just are not going to hire enough PhD data scientists and machine learning engineers to maintain your models. Therefore, you have to come up with automated processes to do it, right? Automated platforms. That's the only way to do it. And on the battlefield, for example, soldiers are not PhD data scientists. Who's going to maintain the ML models and all the data being generated at the tactical edge? It's got to be automated ML ops and automated data management solutions.
Yeah, no, that makes all kinds of sense. So as we take a look at advances in AI and the challenges there, we talked a little bit about the fields in which AI is being employed today. And I was just curious, where do you see, emerging applications or areas in which artificial intelligence offers tremendous promise, but hasn't really yet been implemented, if you can think of any off the top of your head?
I can. One that I'm pretty passionate about is smart cities. I know it's kind of become a buzzword of a bit over the last few years, but if you think about smart infrastructure, just roadways, for example, right? I can tell you, I go out of my neighborhood here, and there are times where I sit at the traffic light for 3 minutes. There are times where I sit for 3 minutes and 3 minutes. The point is, it's always 3 minutes. It is not smart.
Right.
AI, and it is not difficult to apply it to that kind of solution, right?
Sure.
There are already traffic cameras there. An algorithm, there's plenty of data being collected. As long as that data is being stored somewhere, we can pretty easily label it and train it to analyze traffic patterns at that intersection.
Sure.
Now
And
think about
yeah, I was going to say, if you think about Waze as an example, doing real-time traffic monitoring, traffic analysis and traffic control are rife with potential for being enhanced by AI. How much congestion could you reduce if you could intelligently manage traffic signaling and traffic flow?
Yeah,
I agree with you. When I lived in DC, that was my number one thing. I'm like, even if there aren't cameras there are still sensors there pointing at the intersection saying, oh, there is a car here. All right, well, what if you know where all the cars are in a given geographic area and how they're flowing and whether or not there are obstacles or construction or what have you? Being able to maneuver or shift the traffic dynamically on the fly would be an immense benefit.
Absolutely. Throw in weather and other circumstances that impact traffic patterns, and all of a sudden you've got a real-time traffic management and control is that's what I think you said. That's spot on. It's the control part. How do you actually control the flow of traffic? And right, most American cities do not do that. So a lot of opportunity there.
Yeah, in the 90s and the 2000s, when I was in the Army, there was a tremendous amount of emphasis was placed on digitizing the battlefield. That was the buzz phrase. So, smart cities, digital battlefield. And it struck me that digitizing the battlefield was a precursor step to automating the battlefield. So the really interesting, and that was what, one of the fundamental premises behind Land War Net was to do exactly that, was to synchronize and coordinate the combat power to deliver, optimal results, reduce risk, and assure mission success. But functionally, the same kinds of things can happen in a city. How do you deliver better services? How do you deliver more responsive emergency services? What are these things that you can implement to track zoning progress and property usage, sewage, water, electricity, all of it? If it can be metered or if it can be monitored, then we can know something. And if we know something, the question becomes, what do we want to do with that knowledge? What are the desired outcomes? If we know that, then we can start using our telemetry to help us understand what's happening in the city. I agree with you. Smart cities became sort of hackneyed, but the idea behind it is still incredibly relevant and valuable. We've got I am familiar with a couple of customers of ours who actually do this. Some of it in a small scale. The city of Davenport, Iowa, astonishingly technologically advanced for a city of 100,000 people. And they have a very small IT shop, but they do they're punching way above their weight class. They really are. They're also, co-located with Rock Island Arsenal. So they butt up against, a fairly substantial federal entity, and the information sharing that they have to do, particularly for security operations, is pretty significant. So, technology becomes that enhancement to human capability that it's always been since, as I said, we picked up a rock and, so we didn't hurt our hands anymore, or since we made fire. So this, this is also sort of one of those things where we got to be careful. Do you think we see areas where there's potential risk you've already said AI is kind of limited and our management of AI is kind of limited, but learning algorithms do some unpredictable things. So do you see that there are potential challenges there in managing artificial intelligence algorithms, autonomous activity?
Good question. And based on previous conversations with you, Nick, I think maybe we disagree a little bit here, but that's okay. I think it's a good thing. I actually don't think the risks are all that astonishing or all that defined, at least. Maybe years to come, yes. But right now, ML models are so narrow in their capabilities, trained to do one thing really well, right? And they need us to keep feeding them data to get smarter, if you will. I will say also, if I go back and kind of make a high level or general statement on the state of the DoD when it comes to talking about threats, right? DoD specific, DoD has I'll just say an obsession with policy and ethical AI implementation, and there's no telling how many millions of dollars and millions of person hours have been spent on developing those policies that have come out of the Joint AI Center and other places in the DoD. Now, those are millions of hours that could have been spent building actual capability instead of focusing. What ethics are you managing when you don't have an application to apply the ethics to? So I think it's backwards. I think we need some capability and we need to focus more on developing capability because our adversaries are. And I can tell you, if we continue focus on the ethical implementation of things that we don't even have yet, we are going to fall further and further behind. That is a problem. I don't know if that's a popular stance, but I think it's true. As far from a technological perspective, I think there are some things we have to be worried about. One is automated weapons on the battlefield. I do think it's, I know for a fact the technology is there. We can do it today. We can do machine-to-machine tasking and tell machines when to, precision fires and things like that. We can do it. Should we? I don't know. I don't know. That's something I ponder all the time. Our adversaries are working towards it. The Russian version of DARPA, they are actively working towards fully automated squads on the battlefield, infantry squads. That is their goal, fully automate their infantry squads. If that were to happen and we don't have a similar capability or a counter AI capability, that could be really bad news for human squads going toe-to-toe with a fully automated squad. So those are just some of the things I think about, and yeah, we do have to think about our ethical implementation of it, but we also need capability to actually ethically implement.
Sure. So you mentioned the JAIC, the Joint Artificial Intelligence Center. Do you guys do work with, alongside of, in conjunction, coordination?
So we have two vehicles with the Jake. So the TNE, BPA, and then the DRAID, data readiness vehicle. That being said, no, we have not done any contractual work with the Joint AI Center. No.
Just curious. And it's the thing that I think we're at the phase now where the Wright brothers have basically recently flown, and we're still getting to the point where we've got, aviation as a primary operational function in the battlefield. The evolution from Kitty Hawk to, Army aviation and the Army Air Corps and now the Space Force was an arc of decades. And I think that I think Octo Labs is primed to be, a significant partner in the Department of Defense's development of artificial intelligence capability going forward. I like to say, not for nothing, but the armed forces didn't build their own airplanes. They designed their airplanes, but they were built by aircraft companies. I see that similarly happening in this particular area as well, where there will be companies who are specifically very good at delivering AI capability for defense and national security purposes. And I think that O Labs is one of those key players at this point. So I want to thank you very much, Rob, for your insights and for sharing with us what Octo Labs has done, what Octo has done, what O Labs has done, how it's evolved, and what you see the state of artificial intelligence in the DoD and the federal government at large today. Did you have any parting thoughts or observations for the audience before we wrap it up?
I would just say, reach out to us. I'll plug O Labs once more.
Please.
It was an investment that we made, on the order of $10 million to build this facility. 2 years. If anybody's ever tried building something like this, especially in a COVID constrained supply chain, it is painful, but we did it because, obviously Octo and every other firm out there has to keep their lights on. How do they do that? By winning contracts, right? But that's not what it's all about. It's also about delivering AI enabled capability to the warfighter and bringing more of them home safely. And so, but we can't do that if the government isn't bringing us requirements, right? And isn't willing to work with us. So government, reach out, come visit O Labs, partners like Pure. You guys have been great. We're just looking for more collaborative opportunities. And we want, everybody's heard DARPA hard. We want Octo hard problems, right? We're not looking for stuff that's been solved. We want the hardest problems on the planet that the government, almost intractable problems that the government's working on. Bring those to us. We have the best engineers in the world, and we're ready to solve some problems with you.
Fantastic. Well, everybody, thank you very much. You've been listening to the Modern Data Experience, or watching the Modern Data Experience. I'm Nick Psaki, Principal Technologist with Pure Storage, and Rob Albritton from Octo. Thank you again very much. And we look forward to meeting again.
Thank you.